What's up guys, this is Ronnie. Welcome back to our channel Total Technology. This is tutorial 6 and today's topic will be the data types on Rust. Okay, so in the last video and before the last video, which is I believe tutorial 4, we have started the variable declaration, and we like very shortly talk about different data types, but from this tutorial onwards we'll be going to talk about in detail about the different data types. But before moving forward, I would like to say sorry again guys. Again, some construction works are going on in the building, so I did wait for the last 2 days, but they didn't complete. So if I wait, then actually I'm wasting much time for myself and as well for the students those are actually waiting. So just sorry for that. There will be some sort of noise in between, but I'll try to as much as possible as loud and as clear. Okay, so let's start. So every value in Rust is kind of a specific data type. So if you see the slide, you will like clearly understand. So every value in Rust is of a specific type, and this describes what kind of data is being supplied and how to work with that. And in this context, we'll use two data types. One is scalar and one is compound. And one important thing, Rust is a statically typed language, means at the time of compilation, the compiler must know about the data type of all variables. Okay, if you are not able to provide that thing, definitely you will get some compilation error and the program will not compile. So Java is one of the like language which is also for like supports statically typed language. I think C and C++ as well, but Python is not a statically typed language, it is dynamically, so you don't have to worry about your data type. Okay, so we'll explain all this statically or dynamically typed language, the fundamental part of these things in the latter part, as I told you. So now these things is going to be more or less kind of a practical. Okay, so and this like structured contents, actually I took it from the Rust official documentation. So as I told you, my learning types is actually always follow the official documentation of those programming language. So if someone is interested to learn more about those theoretical parts, can just go ahead and learn those concepts from that website. So now we'll talk about scalar data types in Rust. So as per the definition, those are actually coming from physics or mathematics background. There's no scalar means only value, no direction. So here also it is more or less similar. Scalar type represent only a single value. Rust has 4 scalar types: integer, floating point, number, boolean, and characters. And the lastly, as I told you, I got all the reference from this website. So this is Rust official documentation. If someone is interested to learn more and more on the theoretical part, so you can just go ahead and look for this information again. Okay, so what else? Benefits. So this is not the right slide probably. Okay, yes. So actually what I did, this is integer slide. Okay, so yes, so let me delete this slide. Actually this is from the previous slide actually. Okay, now we talk about definition of scalar, then we'll start about integer data type. So let me go ahead. Okay, so integer data type means number without fractional component. Okay, so let me fix this now. Fractional component. So each variant can be either signed or unsigned, has an explicit value. So before that, so number without fractional component is the definition of the integer part. But if you want to know how many like variations are available within the integer data type, so this is the this is a complete table again from the Rust documentation. So see the length, signed and unsigned, and how to denote these things. It is here. 8-bit length means I8. It is means signed, and U means unsigned. So for 8-bit unsigned will be denoted by U8. For 8-bit signed will be denoted by I8. Okay, 16-bit unsigned will be denoted by U16. 16-bit signed will be denoted by I16. For example, for 32 it will be I32, U32. For 64 it will be I64, U64. 120-bit is same. and this is based on the architecture of the computer you are using. Okay, so we'll discuss this thing in the next slide. So next, just go to the next slide. So each variant can be either signed or unsigned, has an explicit size. So we have already seen this. If you go back to this slide, so each variance can have signed or unsigned with explicit size. This is also written. Signed and unsigned refer to whether it is possible for the number to be negative or positive. So signed or unsigned is defined so negative. If it is unsigned, so it means it's always positive. There is no need to define unsigned or positive or unsigned. And if it is always signed, so it means you need to define specifically whether it is positive or negative. In other words, whether the number needs to be signed, it's signed, or whether it will be only have the positive. Therefore, to represent it without a sign, it means unsigned. So whatever we discussed, it is rare. Just forget about this theoretical part. Just concentrate on the actual part. So I32 means it is unsigned. So always the number will be positive. If you defined signed, and if you define with u, it means number is definitely unsigned. Okay, so by default, Rust suppose I32 means a 32-bit signed integer. Let me just, so Rust always, if you are not explicitly mention anything, Rust will give you this thing, 32-bit signed integer. Okay, so next thing, each signed variant can store, okay, again signed numbers are stored using 2's complement representation. Okay, I'm not going to discuss these things. This is again some sort of digital logic or binary number systems things. You guys can go ahead and search in the Google and try to get the actual understanding of this thing. Each signed, this is now important thing, the next two. Each signed variant can store number from -2 to the power n minus 1 to 2 to the power n minus 1 minus 1 inclusive. It means where n is the number of bits. Okay, so just remember this thing. Okay, so for example, if your n is 8-bit number, so 2 to the power 8 minus 1 means minus 127 to plus 127. So 2 to the power 8 minus 1 means what? Anyone knows? Let's check this thing. 2 to the power 8 minus 1. Okay, let me open this thing. Calculator. Well, it doesn't support scientific, so let me check it here from my mobile. So definitely it will be I believe it will be 2 into to the power 7 okay, minus 1 means 127, and then it is going to be 2 to the power 8 minus 1, so minus 127 2, and 2 to the power 8 means 2 1. Okay, so it means here it is actually minus 127 to plus 126, right? So here it is actually 127, and here it is actually this is also 127 minus 126. So this is for I8, it is minus 127 to 126. So similarly for I8 also, I32 also, it will be like this. Okay, so additionally, and for unsigned means if you are signed denotes with u, then it will be starts with 0. So u, it can vary from number 2 to the power minus 1, so it is going to be 2 to the power 8 minus 1, right? So it will be 0. Always for unsigned, it is always start from this, because there is no point of keeping negative, so it always starts from 0 unsigned. Okay, just remember one thing. And for signed, it will always sign from some minus sign. So for unsigned, it is always starts with 0 to 2 to the power n minus 1 means this one. Okay, n minus 1, so u8 is going to be 0 to 2 to the power 8 minus 1. 2 to the power 8 means 2 to the power 8 means definitely 255. Okay, minus 1, So 2 to the power 8 means 256 minus 1 means 255. Okay, additionally the I size and U size, this two special. Okay, I size and U size, let's see. I size is depend on the kind of computer program you are running. 64 bits if you are using 64 and 32 bits if you are using 32-bit architecture. So it means it will be size of 32-bit if you are running on 32-bit architecture, and if it is 64-bit if you are running on 62, and both of these are similar to the signed and unsigned. So now we'll see the integer data type. So there will be one useful case for this thing. So let me open my ID. Okay, so first thing first, let's write down the structure here like this, and after that let me define or declare one variable with this I8, and I will write, as I know it can hold minus 127 to 126, so I will write 100. Okay, and I will try to print it. Okay, okay, let's print this thing. So it should print 100 without any error. Sorry, I forgot to give semicolon here. I always do typo just because I came from Python background. So again some error. I am not sure what I have done wrong now. Okay, again I put print, again Python syntax. Okay, sorry guys. So it will be definitely println. Yes, 100. See, now it is 100. Now if I give it to minus 100 and print, see, it is printing. Okay, so what I'll do now, I will try to print let's say 126. Okay, okay, it is printing 126. So let's now print 127. Let's see what is happening now. It is also printing. Okay, so let's print this now. Let's see what is happening. See, literal out of range for I28. Why this happens? So let's check this thing now. Guys, we have seen here that when we are trying to print 128, it is not able to print this thing. So the reason we have already defined. So for signed integer, it is always like follow this range. So for minus for I8, it will be minus 2 to the power 7 2 to the power 7 2 plus 2 to the power 2 to the power 8 minus 1 means 2 to the power 7 minus 1. So this is going to be minus 127 to plus 127 actually, right? So this is it, guys. So here actually the range is minus 127 to plus 27 for I8. I8 can store numbers between minus 127 to plus 127. And what happened here, if we put 128, it is actually out of this upper bound. Okay, so that is why it is not able to store it. So if I run this thing again, let's say if I run this thing, for example 126, you already run this thing, right? There is no point of doing this thing, but just to make sure, see, it will easily able to print this thing, right? And if I do it for 129, what is going to happen? Let's see. See now, again it is out of this, cos minus 129 is out of this lower bound. So that is why one thing is very much important. If you are not providing any like specific like variant, this is fine. Okay, so Rust will treat this thing. For example, if you are not providing anything, fine, it will work, cause Rust will treat this thing as I32, sorry, I32, it will print. If you are not providing anything, it will be replaced by I32, or it will be like treated as I32. But if you are providing proper type, then you have to make sure that you are dealing with proper values. You know the values, what is going to be the lower bound or what is going to be the upper bound, or else your whole program or whole intention will not be like fulfilled. So that's it, guys. That is the main or important part. I'm not going to discuss the later part like for unsigned this formula and all, because you guys can easily do it by your own. So my objective is to give you guys some sort of intuition towards the data type, what is the essence of data types, and how and why this table is so much important. What is the essence of this I8, I16? So if you are going to deal with I16, then you have to just replace this formula with 16 minus 1 to 16 minus 1 minus 1, right? So same way. And if you are dealing with this unsigned integer, then it will be this 2 to the power minus 1 to this 0 to this thing. So there it will be 0 to 225, because unsigned means always positive. So it will start with 2 to the power n minus 1. If n is 8, it will be 2 to the power 8 means always 256, minus 1 means 2 to the power 55. Sorry, 255. So it will be 0 to 255. So let's discuss this thing. Just have a look on this again. So this okay, and let's run this thing now. See, it will be a problem now if I run this thing. See, cannot apply unary operator cause this is unsigned. So if I run this thing, so this will run now because it is within their bound. Okay, so this is running, but let's suppose, as I told you, the upper bound is 255. So let me write 256 and let's run this thing again. It will fail now. See, this is failing now, out of range. So this is very simple, very easy to understand if you know the essence or the logic behind this thing. So you have to remember this formula. Don't remember, there is nothing to hard code, just follow this table actually. Okay, and if you forget, don't worry, you can Google it. There is nothing to hard code memorization, and if you're writing your code very frequently, you will be easily understand what is happening, what is not happening. So that's it, guys. This is the fundamental part of the integer data types. But if someone is interested to learn more about the theoretical concepts, can just go ahead and get the reference from this URL. So you will get much more idea. It is always good to explore more and more. So definitely it will help you. But one thing I can highly recommend you guys, you are following the documentation or not, that is not the main thing, but start writing your own code. Whatever till now you have done, try to grab everything, try to memorize everything, take a pen and paper and try to write a full code. You will definitely get some more confidence, and you will get your you will gain better visibility about the programming of the Rust. Okay, so that's it, guys. That's all for today. Hope to see you in the next video. Till then, take care, goodbye, and don't forget to subscribe our channel, hit the like button, and also please hit the bell icon so you should not miss any notification from the next time. And those are watching our videos from Udemy, thank you very much for enrolling this course. I will be your instructor throughout the course. Whenever there is any doubt or clarification you guys need, please feel free to reach out to me via instructor message box, and you can reach out to me directly via email. I always provide you the email address at the beginning of the course, so feel free to interact with me. That's it, guys. That's all for today. Hope to see you in the next video. Till then, take care, goodbye, and have a nice day.